guys, today let's talk a little bit about transformations. Transformations are an important tool for studying functions. In this activity we will investigate transformations on the graph of a function. Okay? So the first thing I want you to notice is that these are some given values of our function. Okay? So if I know x is -2, what is my y value? Well, hopefully you remember from last unit that that's a 2. I don't know if you can see that color or not. Sorry, I was trying to get a color that I knew you could see, and I don't think you can see the purple very well. Let's try the orange. 2. Okay? So when the y value of the function is 1, what is the x value? How about -1? When the x value is 0, hopefully you can see the y value is 3. When the x value is 1, the y value is 0. When the x value is 2, the y value is 2. When the x value is something, the y value is -2. Hopefully you see that next value is 3. And when the x value is 4, the y value is 2, like here. Okay? Now, it tells you from the very beginning that it is a function. So we can connect these. Even though they don't make a straight line, even though they don't make a nice pretty curve, it tells us that it's a function, so we can automatically connect those dots. Okay? So on the next page, first of all, what you're given here on this graph is this original function. Okay? And I'm going to keep my page right here, my first page, just kind of right beside, because we may need to use that again. Okay? So right here we have f of x plus 2. Well, what's changing here? Hopefully you can see that the x value is changing. Okay? So if I say f of x plus 2, and they tell me from the beginning we're starting with x is -4, I say f of -4 plus 2, that is f of -2. Well, do I know f of -2? I do. It is 2. Okay? Here, f of -3 plus 2 equals, well, that's f of -1. Do I know f of -1? I do. I know f of -1 is 1. f of -2 plus 2 equals, that's f of 0. And according to the information I was already given, f of 0 is 3. Okay? When our x value is -1, anywhere there's an x, I put in a -1. So -1 plus 2, that is f of 1. And I know f of 1 is 0. Now x value is 0, so I need to say f of 0 plus 2. That's f of 2. And I know f of 2 is 2. So anywhere there's an x, I'm putting in this value right here. So f of 1 plus 2, that is f of 3. And I know f of 3 is -2. Last but not least, f of 2 plus 2 is f of 4. And I know f of 4 is 2. So now I need to plot my new points. The x value is -4. The y value is 2. -4, 2. -3, 1. And I can connect these as I go. -2, 3. Whoops. 3. -1, 0. 0, 2. 1, -2. And 2, +2. So can anybody see how the dotted line, which was our original function, how our solid line, is different than our dotted line? What happened to our dotted line? Where did it shift? Where did it transform to? Well, hopefully you can see that it moved to the left 2. Every point is moved to the left 2. So we're going to go and write that out here. It went left 2. We start at the dotted, go to the solid that we just drew. Okay? I'm going to let you do number 3. Okay? After you do number 3, compare them to. Okay? See if you can figure out what was constant, what stayed the same, what changed, all sorts of stuff like that. Then describe the effect of the graph by adding a constant inside with the x. Okay? Look at number 5. Number 5 is different because we're starting with a value we know, with a specific x value, and we're adding something to its value. So we're putting in something for x and we're getting a y value and adding something to the y value. In this problem, we added something on the inside. We added something to the x value that changed what we got out. Okay? We're going to kind of get the same thing out, but then we're going to have to change something to that. So let's start. Anywhere there's an x, I'm going to put in a -2. So f of -2 plus 2. Well, f of -2 is 2. This is 2. What is 2 plus 2? Well, that's 4. Let's see. F of -1 plus 2. See how the plus 2 is on the outside of the parentheses, not like on the inside of the parentheses like number 1 that we just did. Okay? F of -1 is 1, so we have 1 plus 2, and that's 3. F of 0. F of 0 plus 2. Well, f of 0 is 3. What is 3 plus 2? Well, that's 5. Okay? F of 1 plus 2. F of 1 is 0. So 0 plus 2 is 2. F of 2 plus 2. F of 2, the value of that is 2. And 2 plus 2 is 4. F of 3 plus 2. The value of f of 3 is -2. So -2 plus 2 is 0. And last, f of 4 plus 2. Well, f of 4 is 2, and 2 plus 2 is 4. Okay? So now let's plot this new function. -2, positive 4. -1, positive 3. Again, we're going to connect as we go. 0, 5, 1, 2, 2, 4, 3, 0, and 4, 4. From our dotted function to our solid function, our original function to our transformed or changed function, what happened? Can you see that there's some sort of shift or slide or transformation? Okay? Hopefully you can see that it moved up by a factor, just up 2. Okay, we'll get to the factors in a second. Every point is 2 higher than it was before. It's just shifting up 2 from where it was before. Okay? So you do number 6 and then compare 5 and 6, see what's the same, see what's different, and see if you can describe the effect of the graph by adding or subtracting a constant from the function of f. Okay? Number 8. Number 8 is a lot like number 2 in the fact that we're changing stuff that's inside of the function value. Okay? So we're saying f of 2 times -1. Well, f of 2 times -1 is f of -2. Do we know what f of -2 is? Yes, we know that that is 2. F of 2 times -0.5. Do we know 2 times -0.5? Well, that's -1. And do we know f of -1? Yes, that value is 1. Okay? F of 2 times 0? Well, that's f of 0. Do we know a value for f of 0? Yes, that's 3. F of 2 times 0.5. 2 times 0.5 is 1. So that's f of 1. And we know a value of f of 1 is 0. F of 2 times 1, well, that's f of 2. And we know a value for f of 2 is 2. F of 2 times 1.5, do we know 2 times 1.5? Well, we know 2 times 15, right? That's 30. Well, we have a decimal place, a decimal point in there. It's really 1.5 and not 15, so hopefully we can figure out pretty quickly that that's 3 without using our calculator. And we know that f of 3 is negative 2. Okay? F of 2 times 2, f of 4. Well, f of 4 is 2. So let's plot our new function. Here's my x's, here's my y's. Okay? When x is negative 1, y is 2. When x is negative a half, y is 1. When x is 0, y is 3. Oops, connect as we go. When x is 0.5, y is 0. When x is 1, y is 2. When x is 1.5, y is negative 2. And when x is 2, y is positive 2. So, can anyone think about what happened to that function? Look at your paper. Try to do something with your hands. Either, when it was shifted left before, we went that way. When it shifted up, we went that way. What kind of things are we doing on our hands, with our hands on this original function, the dotted function, to get to the solid function? Can you see that we took the function and went like this, whoosh, and squashed it? Okay? That is going to be, well, what do you want to write? You just want to write squash? That's not technical. But I will teach you the real word to use tomorrow. How about that? Okay? Here, I'll actually teach it to you today, and then we can talk about it tomorrow. This is a compression. Okay? It's a compression. And we're going to say by a factor of a half. Can you see that it got half as skinny as it was before? It used to go out to 4. The end used to go out to 4, but now the end only goes out to 2. On this side, the end used to go out to 2, but now the end only goes out to 1. So do you see it only went half as far as it did before? Excuse me. So you do number 9 and number 10. Okay? You'll have the rest of the time in class to do also 11 and 12. Also, 13. And then 14, 15, 16, 17. Are there any questions about that? Now, you may have 18, 19, 20, and 21 on your paper. If you do, you do not have to do those tonight. We will talk about them tomorrow. Okay? So please, quietly, alone, please work alone today. Use your calculator as much as you need to, and work on the rest of these. So just to make sure you know what I expect, number 3 and number 4, number 6 and number 7, number 9 and number 10, and then all of the rest that we didn't do. 11, 12, 13, 14, 15, 16, and 17. Okay? Again, like I said, you may have 18, 19, 20, and 21 on your page, but you will not be required to do those for homework tonight or even in class. Okay? We will discuss those tomorrow. Please behave, and I hope you have a wonderful day.